Good morning to both of you. Students, did we finish practical of circular cube? In the last lab, did we finish circular cube? Yes or no? I'm asking you.
No, ma'am.
Darshan, what we completed in circular cube?
मैम डिस्प्ले किया था, इंसर्टेड बिगनिंग एंड इंसर्टेड एंड, दो तीन फंक्शन किए थे।
ये तो सिंगली लिंक लिस्ट है। सिंगली लिंक लिस्ट चालू हो गया आपकी बैच में?
यस मैम, मैं चेक करके बताता हूँ।
इतना आगे पीछे कैसे हो गया? See students, did we complete these two? Insert the node at the front and insert node at the end of the linked list.
हाँ मैम, वो दोनों किए थे।
ओके ठीक है, देन विल प्रोसीड फर्दर। क्योंकि कल ऐसा हुआ था कि मैंने ये दोनों स्टार्ट कर दिया था, फिर आखिर में उन लोगों ने बोला कि सर्कुलर क्यू का डिस्प्ले बाकी है। आई वाज लाइक कि वो कैसे बाकी हो सकता है, मैंने तो कंप्लीट करवा दिया है। ठीक है, कोई बात नहीं। तो आई थॉट बेटर टू आस्क यू गाइस आल्सो दैट circular queue is done or not. I'm going to start in a minute. Meanwhile, open up your programs for singly linked list, which you have implemented in last session. We are going to continue with that program only. You don't need to write any new code. We are going to continue with that code only.
Morning, ma'am.
Good morning.
मैम तब तक एक डाउट पूछूं?
हाँ पूछ लो, क्या हुआ? राज पूछ लो, क्या हुआ?
हाँ हाँ मैम, रुको रुको मैम, प्रेजेंट करूँ स्क्रीन?
हाँ करो करो, मैं अपनी बंद कर देती हूँ, रुको।
मैम दिख रहा प्रोग्राम?
हाँ
मैम नॉर्मल क्यू में एन क्यू वाला ही है।
ओके।
तो इसमें फ्रंट और रेयर और क्यों डाला मैम? एंड आना चाहिए ना।
नहीं, देखो यहाँ पे है ना, एंड भी लिख सकते हो और भी लिख सकते हो, या तो फ्रंट इक्वल टू -1 या तो रियर इक्वल टू -1। क्योंकि फर्स्ट देखो ये एन क्यू का है, ठीक है, एन क्यू ऑपरेशन है, तो वी नो दैट इफ इट इज अ फर्स्ट एलिमेंट तो दोनों ही चीज को हमें इंक्रीमेंट करना है, ठीक है। वरना तो
हाँ
अगर फ्रंट -1 है और रियर भी -1 है तो ऑब्वियसली समझ आ गया कि आपका क्यू एम्प्टी है, ठीक है। तो कोई भी एक यूज कर लो क्योंकि दोनों -1 को ही पॉइंट करेंगे, तो दैट्स व्हाई इट इज, और वहां पे आप एंड लगा रहे हो तो भी गलत नहीं है।
यस मैम। तो मैम एक -1 है तो मैम दूसरा और कुछ हो सकता है?
नो नॉट पॉसिबली। ये सर्कुलर क्यू है या नॉर्मल?
और नॉर्मल क्यू है?
हाँ तो नहीं।
नहीं, ओके मैम। तो मैम ये डी क्यू में भी सेम ही है?
डी
ओके
क्यू
मैम,
में
बस
हाँ।
ये रहा। और ही डाला है, बस वही था। थैंक यू मैम।
ओके। Okay, students kindly open up your singly linked list program. You must have done two operations in that in the last session. So we are going to continue with it. I told you to save it somewhere. What does it say, Yasi? Okay, just give me a minute. Oh, this is made so strict. See, I'm talking about this program. Anybody else facing the issue to open up this program? Apart from Yasin, anyone else facing the issue? Yes or no, student? See, this particular program should be there with you. Why I am asking? So that I can circulate this program and you don't have to waste your lab's time to, again recode. But there is an also, a warning from my end. This is not going to happen every time, okay? This is this time for which I'm going to circulate this code. So do tell me if your file is getting corrupted, or it is not opening, or you don't know the issue why it is not opening, anything like that XYZ, and you cannot access your previous sessions file, then tell me. I'll send you this file so that you can work in the next third, fourth, and fifth case. Anybody else like that? Otherwise, it is only Yasin who is getting the file. Okay. Just let me have a look. Insert at the end. Okay, it is there. Insert at the end, my void main. I'm creating my SLL, and then I'm giving the choice. Okay. And in the choice I have display, so display function is there. Insert at the beginning is there. Okay, this file is ready. Yasin, paste your email ID here. Yasin, place your email ID here in the chat. Okay, thank you. Sorry, I'm not attaching a file. I'm directly, copy pasting the code in the mail. So please bear with me. Okay.
Ma'am, will you please forward me that too?
Okay. What is this SLL?
क्लास के ग्रुप में ही डाल दो मैम.
नहीं, ऐसा नहीं करना है. प्रांजल, अपना ईमेल एड्रेस पेस्ट करो यहाँ पे. देखो ये चीज है ना, पहली और आखिरी बार हो रही है. ये मैं वापस से बार बार ऐसा नहीं करने वाली मैं. So next time please save somewhere, either in the notepad file, otherwise. ठीक है? See students, again those who have joined the session, ये वापस से उनके लिए मैं repeat कर रही हूँ. We are going to do your practical number 7, okay, which we left by doing these two programs, insert at the front and insert at the end. Okay. Now we are moving forward with the remaining insertion, and then we'll go for delete. And to move forward,
प्रैक्टिकल वाली पीडीएफ फाइल आपने अपलोड नहीं किया ना अभी तक कहीं पे?
ये वाली?
हाँ मैम, पूरी पीडीएफ जिसमें प्रैक्टिकल क्वेश्चन लिखे हैं.
डियर, वो सिलेबस की फाइल नहीं है, ये आपका सिलेबस का फाइल ही है, देखो.
अच्छा, इससे नीचे कभी देखा ही नहीं मैम.
हाँ, सिलेबस की फाइल में नीचे स्क्रॉल करोगे तो वहां पे एक्सपेरिमेंट्स आ रहे हैं.
Hello, ma'am.
Yes, Mohammed Yasin.
Ma'am, will you please upload the PPT of the linked list?
Okay, fine. I'll break it down because that linked list PPT is too huge, and we have not covered many of our topics there. They are yet to be covered. So fine, I'll just break it down and I'll upload by the end of this session.
तुम पूरी डाल दो आगे.
So I suppose now everybody. Everybody is having the file now? Students, yes or no? I'm starting with the experiment, okay? See, what is our target now? Third option. Third option is to insert a node in such a manner that your linked list is in ascending order. Okay, and it is mentioned that it should be according to the information field. Information field means your data field. Okay, so what will be our approach here? Okay, this is from the yesterday's part. Okay, I'll just. What will be the flow today? First of all, you are going to create a user-defined function, okay, with some meaningful name. Let's say insert in ascending. Okay. Now here this function, what you need to take first of all as input. What will be your input? User inserting the number or say the data part, okay, of your new node. So when I say new node, you should, directly come into your mind what things that you have to allocate a memory to the new node using your malloc. Okay, new node of data part you are going to take with the help of your printf and scanf statement, and next part for now you can initialize to 0. Okay, these things should be coming into your mind when I say insert a number of a number inside your new node. Okay, not off. Fine. So that is the input part from the user that we are going to fetch. Now what you need to do? You need to second thing. Okay, in this particular program only. Second thing, what you need to do once you get the input, you are going to compare. Compare with whom? Compare with the node data part. Okay, suppose I have a singly linked list with node values as 26, 58, 66, okay, and 75. Okay, and the node value which I am entering, okay, node value which I am entering is, let's say, 45. Okay, then you have to compare this 45 with each of these data part of your singly linked list. All right, so there will be one while loop. Okay, just to for the comparison, there will be a while loop while new node data is less than temp data. Okay, or you can write a vice versa condition also. Temp data is greater than new node data. Okay, any condition which you like, because we want it to be in ascending order. Okay, so we are going to compare this. 45 less than 26, no. 45 less than 58, yes. So we got the position that 45 should be placed between 26 and 58. Okay, so in order to place this 45 here in between, okay, we are going to take two pointers. One pointer is PTR, another is pre-PTR. You might have heard this. Okay, this should be now familiar to you because in our theory session, we have used these two pointers. So with the help of these two pointers, okay, we are going to update, we are going to place this 45 here. Now what is one thing you need to keep in mind while going for this insert in ascending order is that while you are creating your singly linked list, okay, in this program here in your void main, you are first of all going and creating your singly linked list. Okay, so there how you are going to create, you are going to create in a manner that it is already existing in ascending order. Okay, because why? Because in this particular program it is said that insert a node such that linked list is in ascending order, and linked list should be existing. Then only you can insert a node. Okay, and we have not yet seen our sorting techniques. Okay, so what we are taking as constraints here, the constraint is that your singly linked list is already existing in ascending order. Okay, that is the constraint. That is what you need to keep in mind. Now let's see the algorithm for this particular operation first, and then we'll start coding. Where is it? Here. Understood the flow of the operation for inserting it? Okay. See, first of all, you are going to write down, you're going to write the main part here in the switch case. Inside your main, you are going to add one insert in the ascending order case. Okay. You can copy paste the name from here. All right, so you can avoid your any kind of spelling mismatch. Now you can go back up here where you have stored all your previous user defined functions. Void insert ascending order. Okay. Now, first of all, what you are going to do, again, new node equal to, you are allocating the memory, okay, for the node. Struct node star malloc excuse me, size of struct node. All right, this is your allocation of the memory for the new node. All right, now what you are going to do as input, we have to fetch input from the user, so your printf statement. Before that, now what I want to introduce you guys is, you might have seen, telling me that I have told you many times in the session that these step number 1, 2 and 3, if avail is equals to null, new node equal to avail next, okay, these are handled by your OS. So I would like to show you how they are handled. See, this new node, we know that it is going to get some memory address, okay, via malloc. Now what this malloc is going to do, when you execute this line of code, okay, this malloc is going to OS. This malloc function is going to OS. OS is having a free pool, okay. Avail is the pointer in that free pool. So wherever avail is pointing at, that particular memory address is assigned to this new node. Okay. So when does this scenario comes? If avail is equals to null, how can I tell that avail is equals to null? By writing this particular condition, if new node is not equal to 0, that means new node did get some memory value. Okay, then you are going to proceed with this user defined function. But if your new node is not getting any memory address, okay, then else printf memory is full. though you guys won't get this scenario, okay, you won't be facing this scenario where you are getting an output with a printed statement as memory full, because in our laptops, in our PC which we are using, okay, we are not running any complex programs which are consuming lot of memory. And in the end, when we are running this particular program, the new node is not assigned any memory. This won't happen. This won't happen even in my laptop also. Okay, but if it happens, if sometime it does happen and you have not written this if else loop, okay, then what will be the output? Console will be running. Okay, the black screen console output will be running for you, but there won't be any operation when you are calling this insert ascending order. Why? Because new node did not get any allocation. Okay, so whatever you have written for this new node did not get executed at all. Fine. So you won't be knowing that exactly what happened. There will be a black screen. So what you will be thinking, my program is running, but I'm not getting the output. Actually, the thing is your program is not running. Your program just stopped in between, but because you have not written any printf statement for the user, you don't know exactly what is the problem. The problem is memory did not get assigned to the new node via malloc, and that's why memory is full, and so it has not executed. So this is how you can handle that exception if that exception is coming. This is how you can handle it. That if new node is getting a memory, then only move forward with the coding of your UDF. Okay. But if this new node is not getting any memory allocated, then simply print your memory is full. Okay, so you'll get to know that because memory is full, my program, my user-defined function is not working. Okay, so this is what I meant when I'm writing in the algorithm these 1, 2, and 3 steps. Okay, these 3 steps are handled by your malloc here. Okay, this one single line of code is handling those 3 steps. So I wanted to you guys to understand why I'm writing that and why it is important for you also to write it in the algorithm. Okay, this is the scenario. Okay, now we'll write the coding for your UDF. Okay, we have this new node allocated. Fine. So here you can write your printf statement, printf enter the data of the node to be inserted in ascending ordered singly linked list. Okay, just to differentiate. Okay, that's why I'm keeping a different printf statement here. Then store it, whatever the value you're getting, store that. Where are you going to store? And person new node data part. Okay, now what you are going to do? While you can take 2 pointers. Okay, first of all, temp is equals to head. Okay, and pre-temp equal to temp. Okay, you need to declare this pre-temp. We have not declared that, so we are going to declare it here. That is your pre-temp. Okay, now while temp of data is less than new node data. Okay, something to be written inside my while, and this will be the end of my while. Okay, now see here what you are going to do. You are going to move your temp and pre-temp. Okay, so pre-temp is equal to temp. Okay, even if you don't write it here, it's okay. and temp is equals to temp of next. Okay, so we are comparing what is temp data wherever the temporary pointer is pointing in your existing singly linked list. That data we are comparing. If suppose what was our data here, the string was this one, right? Let me just copy it and paste it there. This was our string. So if my temp is here, okay, at 26. At 26, I have my temp pointing. Okay, so 26 less than 45. So yes. So what will do be here at 26? At 26, I'm denoting pre-temp as P. Okay, so pre-temp will be at 26, and this temp will move to 58. Okay, now temp data. What is temp data? 58. 58 less than 45? No. So you are not going to execute these, these two steps. So now we have two pointers placed. Pre-temp is at here at 26, temp is at 58. And now we want to place this 45 in between them, right? So what we are going to do, first of all, we need to update some links, right? So how we are going to update it? See, pre-temp of next, okay, the pre-temp next portion, which is right now pointing at this node 58. We need to point it to 45. Okay, so pre-temp of next is equal to new node. Done. Then new node next, because we are yet to give the value to the new node next. New node next is equals to temp. Why? Because we want that in between. Okay, so we are done. So what we did, I'm just removing it from here. Okay, we placed this 45 here in between. Pre-temp of next. Pre-temp is where? Here. Pre-temp of next is equals to new node. So we pointed the pointer here to the new node. This pointer now should point to 58, right? So new node of next is equal to temp. Okay, so now you can see we have created a list in ascending order: 26, 45, 58, 66, and 75. Done. This is how we are going to code. Okay, I am keeping this logic here for you. And in the third step, not here, sorry, update the pre-temp next and new node next values. Okay, start coding. And see, students, again I'm saying, if you are stuck somewhere, if you are not able to do it, okay, due to one of the reasons, due to some of the reasons, I don't know which reason is that, but due to any kind of reason you are stuck somewhere, you are not able to do it, or your program is not running, then ask for help. Okay, nobody is going to know that you are into the problem unless and until you don't ask for help. So if you are answering me as yes, or even if you are not answering when I'm asking that program is done, any doubt or any problem, then I'll take it as there is no problem, because you didn't spoke that there is a problem. Okay, I told this in yesterday's batch also, I'm telling it today also. Okay, and I intend to tell the other batch, the Tuesday batch also, the C batch, which unfortunately I'm not meeting that frequent. due to some of the other reasons. But fine, I'll tell them also. Please kindly ask if you're stuck somewhere. Okay, simply sitting and watching the screen won't get you anything. I'm giving you 5 minutes, 5 to 7 minutes. You can take it to write this particular user-defined function. Okay, and just try it out whether it is working or not, and tell me. Okay, after 5 7 minutes, I'll ask you to present your respective screens, and do not hesitate. Okay, even if you are not completed, it's okay. I might help you out. If you have finished also, then also you can tell me. I'll just come and see it. Okay. Anybody finished, completed that UDF program? Anyone? Nobody yet? Facing any issues? Any problems? Okay. Vijay,
Yes, ma'am.
present your screen.
Yes, ma'am. Just a minute.
विजय प्रेजेंट कर रहे हो या नहीं? मैं वेट कर रही थी।
मैम 1 मिनट पीछे से ज्वाइन करके कर रहा हूँ प्रेजेंट।
अच्छा ओके, कोई बात नहीं। तब तक मैं किसी और को पूछ लेती हूँ। पेमा,
Yes, ma'am. Present.
Present your screen.
No, ma'am.
Why?
No, ma'am.
Why can't
Due
you
to network,
present?
there is network issue in my country, ma'am, so I couldn't attend class.
I hope you are coding then. Darshan, Parmar,
Yes, ma'am.
present your screen.
1 minute, ma'am.
Vijay, I can see your screen.
Yes, ma'am.
Oh, you have taken into consideration the situation where single linked list is not existing. So head
Yes.
equal null. So head is not your head is then pointing to your new node. Okay. Uh, though as such is it is not required because we have made it a constraint that before operating the operations, keep it. Don't remove it. It's okay. But in the beginning only we had a constraint that to do these all 6 operations, your single linked list should be existing. It's okay. If, even if you have coded, it's fine. Okay,
Ma'am,
scroll
ma'am,
down.
what I need to do here in if condition after this?
Pardon, I didn't understand your question. Pardon again.
Ma'am, what I have to write this in if condition? Like if the data part is greater than.
You're talking about this if head equal null, that
Yes.
condition.
Ma'am,
You don't have to take this if and else actually. This if and else if in a case where there is no single linked list existing, your head is pointing at null, and so you made this new node to be, pointing by the head, pointed by your head. Okay. Actually, you don't need this if else loop only. You can directly go with temp equal to head.
ma'am, I'm talking about temp and pre-temp, ma'am. How to update them?
How to?
Ma'am, pre-temp and temp. How do I insert that after in ascending order?
Okay, got it.
So, ma'am, is this
You are
condition
not,
correct?
no, that condition is fine. But inside that, if temp of next is not equal to null, okay. What you can do is what you can modify the condition which you have written in your if condition statement. Okay, np data no, less than temp data. That condition, that if condition statement, you need to write in your while loop. Okay, because temp of next won't be equal to null.
Ma'am,
You got
and
confused. See, you got confused actually. What is the constraint? Okay, here constraint number one. Your singly linked list is already existing. Okay, and
yes, ma'am.
constraint number two, the singly linked list which is already existing is present in the ascending order itself. Okay, so in between that ascending ordered existing singly linked list, you have to enter the node. Okay, we are not looking at inserting the node after or inserting the node before. So what you need to do is you can remove this if else loop. Okay, remove in the sense just modify your code, that's all. You can remove from if to else starting curly braces, you can remove that much of line. Yeah, remove that. Okay, now modify your while condition statement. Okay, temp of next, yeah, you can remove that, and that np data part you can write it in that inside your while loop, while condition. Yeah, now remove that if. Now you don't need that if. The while loop is going to run for you. Okay, up till which part it is going to run? Till your np data is not less than temp data is true. Okay, at that many times this while loop is going to run. Once it reaches a condition where np data is less than your temp data is false, okay, then you can update your temp of next and your np next. See, have a look at my screen, okay, and then compare your while loop. Have a look at my screen. You can stop presenting. Otherwise,
Yes,
your
ma'am.
code is fine. Otherwise, the code is okay. Just compare it with my screen. I'll show you. See, what is my aim? I want this 45 to be placed in between my 26 and 58. Okay. So what I am doing is temp data less than new node data. You have done the inverse. That is also fine. New node data less than temp data is also okay. All right, you have to just tweak your program accordingly. Mine is what? The temp data is what? The data which is existing already in my single linked list. Okay, so temp data less than new node data. If this condition is true, then my temp and pre-temp should be moving, okay, inside my single linked list. So what I did, first of all, what is I can just move this. First of all, because I have written here temp equal to head, okay, so T will be pointing at 26, okay, node value 26, T is my temp, P is my pre-temp, okay. Now temp data, what is temp data? For 26. What is new node data? 45. So 26 less than 45, right? Correct. So it is going to go inside. Okay, inside what I'm executing, pre-temp should take the position of temp and temp should move forward. Okay, so pre-temp took the position of temp and temp move forward. Now again your while loop is going to run. 58 less than 45, so it is false. Okay, so these both pointers are not going to move ahead. Now what I need to do, now see, I know that if you want to imagine it like a node, then I can do that also for you. See, there is let's say a memory address pointed to 58. Okay, so let's say the memory address is 1. Okay, so they are pointing to 58. Okay, 1 is the memory address of node 58. Okay, this node is pointing at memory address 2. this pointing at 3, and this pointing at null, so 0. Okay, now what is my aim? I want to place this 45 in between here. Okay, but see, this 45 memory allocation of that 45 is, let's say, 6. It is right now 0 for now, but memory address which is allocated by your malloc is 6. Okay, for this particular. So what is my aim? This pre-PTR, okay, should point to 6. So here value should be 6. Then only I can say this 45 is in between 58, and this 45, this 0 value should have value as 1, because 1 is the memory address of this one. Okay, so what I'm going to do in order to place this here in between, okay, in between these two, what I need to do, I need to update my pre-temp of next. What is pre-temp of next currently? It is 1. So I update it with my new node. What is the memory address of my new node? 6. Okay, so I update it to 6. Now my new node should also point to its consecutive node, right? Right now it is having value 0. Okay, so new node next equal to its next node memory address is stored by your temp. So whatever value temp is pointing at, okay, so it was 1. Okay, so now you can say that your 45 is placed in between your ascending order singly linked list. Got it?
Yes, ma'am.
Okay. Raj, done? Okay, Darshan, is it working?
तो मेरा रन तो हो रहा है, लेकिन डिस्प्ले फंक्शन अभी तक डाला नहीं है, तो कुछ ज्यादा खास आइडिया नहीं आ रहा.
हाँ तो डाल दो.
ओके मैम.
Guys, you know how to write display function?
यस मैम. फॉर लूप.
Huh. See, for those who do not know, this is your display function. Okay, you have to take a temporary pointer to point towards your head, because head is the starting point of your singly linked list. Okay, so temp is equals to head. Now while temp of next, the next part of your node is not becoming 0. Okay, so temp of next is not equal to 0. You need to print the data wherever the temp is pointing at. Once you print it, move your temp to the next node. Okay, now there will be a scenario when temp is at next node and you are checking this condition, temp of next not equal to 0. Now we know that it is singly linked list. Last node next value will be, obviously it will be 0. So this printf statement is not going to run. So in order to print the last node data, we have to write printf statement again here. Okay. See, I'll show you and run the program. Enter the data. Okay, I'm getting asked here to enter my data. This is for creating the singly linked list. Okay, so I'm demonstrating you both the functions, display also and insert in the ascending also. Suppose I start with 50. I want to continue, yes. 60, yes. 70, yes. See, I have called that display function again and again. Okay, so 50, 60, 70, they are getting printed. First it was 50, then 50 and 60, then 50, 60, 70. Okay, and one more I can add, 80. Now I don't want to add anymore. So see, my singly linked list which is existing is of 50, 60, 70 and 80. Now it is asking me for the operations. Okay, let's go for the third operation, that is insert node in ascending order. Okay, so number 3 is here. So it is asking me enter the data of the node to be inserted in ascending ordered singly linked list. Okay, let's say the data which I want to enter is 75. Okay, so it should be ideally between 60 and 70. Let's say it is coming. Do I want to continue? No.
70 and 80 के बीच में आएगा ना?
हाँ, सही कहा। रात जग रहा है, बाकी सब सो रहे हैं। बाकी को क्यों स्ट्राइक नहीं हुआ? बाकी के लोग क्या कर रहे थे? सिर्फ राज को ही क्यों सुनाई दिया, जबकि मैंने इतना जोर से बोला कि 60 और 70 के बीच में, फिर भी किसी ने मुझे करेक्ट नहीं किया, क्यों? जरूरी नहीं है कि हर बार मैं ना सबके नाम बोल के सबके पास चैट बॉक्स में यस लिखवाऊं, ठीक है? ये भी एक तरीका होता है जानने के लिए कि स्टूडेंट्स एक्चुअली है सेशन में या नहीं है। ठीक है, डू आई वांट टू कंटिन्यू? यस, आई वांट टू कंटिन्यू बिकॉज आई वांट टू डिस्प्ले। ओके, सो आई विल गो फॉर ऑप्शन नंबर 4। सही जगह पे है ना? अभी तो देख लो। गुड मॉर्निंग पीपल, है सही जगह पे कि नहीं है?
हाँ मैम है।
देखो अभी भी सिर्फ राज ही जग रहा है, बाकी के लोग क्या कर रहे हैं? श्री, विजय, ऋषभ, प्रीत, अभी ऐसा मत बोलना कि स्क्रीन ही नहीं दिख रही है, क्योंकि स्क्रीन तो दिख रही है, मेरे दूसरे डिवाइस में भी दिख रही है। ओके, मेरा जीरो ऑपरेशन नहीं चल रहा, देखना पड़ेगा। चलो, हो गया सबका? डन एवरीवन?
मैम एक मिनट, मैंने मैम डिस्प्ले का केस अलग नहीं बनाया है, उसमें ही नीचे डिस्प्ले जैसे अपन ने ऊपर इंसर्ट एट बिगिन में किया था ना, वैसे ही डिस्प्ले रखा है, अलग केस नहीं बनाया, तो कुछ हो नहीं रहा है उससे।
प्रेजेंट करो स्क्रीन।
यस मैम। रन करूँ मैम?
हम्म,
एक मिनट वापस। देखो तो मेरा डिस्प्ले यहीं पे हो गया। इंसर्ट एट बिगिन में वो था, अब इसने वापस चॉइस पूछी तो मैं असेंडिंग चूज कर रहा हूँ। अब 45 हो गया, खत्म।
ओके।
अलग से डिस्प्ले बनाना पड़ेगा ना?
या तो फिर है ना डिस्प्ले का फंक्शन वहीं पे कॉल करवा सकते हो एंड में।
मैम ये रहा, देखो करवाया।
कहाँ?
अच्छा नहीं करवाया, कहीं और करवाया फिर।
वो फंक्शन कॉल करवा दो उधर। अगर इफ यू आर नॉट कीपिंग इट इन द मेनू, देन जस्ट कॉल दैट फंक्शन एट द एंड ऑफ योर यूजर डिफाइंड फंक्शन।
मैम पहले कॉल करवाया था फिर भी यही आया, इसलिए फिर मैं ऊपर केस बना रहा था और इतने में
ये बीच में टेम्प इज आके फिर 50 क्यों आता है?
मैम ये ऊपर इंसर्टेड बिगिन में बताया था ना कि अपना टेम्प कहाँ पे कहाँ पे हो? मैम हाँ मैम वो तो मैंने ध्यान नहीं दिया मैम। ये रहा डिस्प्ले में।
हाँ, तो वो डालने की जरूरत नहीं है, उसको हटा दे।
निकाल दूं?
नहीं, रुको 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 रुको, तुमने तुमने एक मिनट, टेम्प इज हटा दो। ये जो टेम्प इज लिखा है ना /n तक, वो हटा दो। किया सही है, लेकिन ये स्टेटमेंट लिखने की जरूरत नहीं है, क्योंकि हमने लास्ट डेटा हमको प्रिंट करवाना है SLL का। बाकी सही किया है, ठीक है।
ओ वापिस रन करूँ अब?
ऑफ कोर्स, लेकिन इतना सारा नोट्स मत डालना, 2-3 डाल के फिर ऑपरेशन दिखा दो।
ओके मैम 4 डाले थे।
हाँ, तो 2 ही डालना। हाँ
कर दिया ना मैंने, एक ही डाला अब।
हाँ 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 हाँ, देखा मैंने।
दो डाले। लास्ट वैल्यू तो नहीं आई? अच्छा, आ गई
आ
20।
गई, दोनों आ गई। अभी 3 करो और 15। हाँ,
आ
हो
गया।
गया, चल रहा है।
यस मैम मैम पिछली बार टाइम पाया था ना तो शायद इसलिए।
ठीक है,
थैंक यू मैम।
ओके। श्री,
यस
हो रहा है कि नहीं हो रहा है?
हो रहा है मैम। मैम थोड़ा मेरा नेटवर्क इश्यू है, इसलिए अच्छा से नहीं हो रहा है। होना तो हो रहा है लेकिन।
ओके, ठीक है। स्क्रीन प्रेजेंट के लिए नहीं बोल रहे हो, इतना ट्रस्ट रख रही हो कि बोल रहे हो कि हो रहा है, तो ठीक है, आई एम एक्सेप्टिंग दैट।
हो रहा है मैम।
ठीक है, ठीक है। ऋषभ, है या चला गया? नहीं, है, ऋषभ है। ऋषभ, if you can hear me, answer me. Yes or no? हर्षवर्धन, क्यों लेट हो गया आज?
मैम वो फोन बहुत हैंग हो रहा है आज, पता नहीं क्यों। ये चैट बॉक्स भी नहीं चल रहा था। आपने बोला ना, मैंने तुरंत यस मैम लिखा, फिर भी पता नहीं इतना लेट सेंड हुआ है।
ठीक है, कर रहे हो कि नहीं कर रहे हो?
नो मैम, काम चालू है, बस वो मैंने ज्वाइन इस पे करा हुआ है, वो लैपटॉप से वो कनेक्ट नहीं कर रहा है।
ओके, फोटो भेज सकते हो व्हाट्सएप पे?
हाँ मैम, अभी अभी कर दूं या?
हाँ, अभी
मैं अभी
भेजो
भेजता हूँ
व्हाट्सएप।
आपको। हाँ हाँ।
ठीक है। Students, with this we are finishing your three insert functions. Okay, if we have time after we finish
हेलो
all of our, हाँ ऋषभ,
मैम, वो लास्ट टाइम मीटिंग में मैं अनम्यूट करके बोला, चला ही नहीं, मैं इसलिए अभी रिज्वाइन करा।
हाँ कोई बात नहीं, इट्स ओके। हो रहा है कि नहीं हो रहा है, बस ये पूछना था। प्रोग्राम कर
हाँ
पा रहे
मैम,
हो?
हाँ मैम, हो रहा है। और आज ऊपर से थोड़ा लेट ज्वाइन हुआ था मैम, तो बस और कुछ नहीं।
हाँ
ऊपर से मैम
वो मैंने
गूगल मीट पे मैम डेली इश्यूज आ रहे हैं मैम, हर काफी लेक्चर्स में आते हैं गूगल मीट पे इश्यूज।
इट्स ओके ऋषभ, कोई डांट नहीं रहा है। मैंने सिर्फ ऐसे ही पूछा था हर्षवर्धन को भी और आपको भी। मैं यही पूछना चाहती थी कि क्या रीजन है, बस, और कुछ नहीं। इट्स ओके।
यस मैम।
As far as you guys are, completing the stuff, coping up with the missed session, okay, I don't have any problem. I do understand network के issues होते हैं, मैं खुद face कर रही हूँ, ऐसा नहीं है. But fine, nobody is, scolding anyone here. I just wanted to know the reason.
ओके मैम, थैंक यू मैम।
All right. And one more thing, see students, again I'm saying, अगर कहीं पे भी है ना कुछ भी प्रॉब्लम आ रही है, not just I'm telling you, not just as your subject faculty, of course it is with concern with DS also, but also as your CC. Okay, if you're facing any problem, then if you don't reach out for help, you won't get help. Okay. uh, ये मैं इसलिए बोल रही हूँ, आई एम सेइंग दिस बिकॉज in my yesterday's session I did find out that due to the weak base of C language, okay, students are very much efficient in the theory part of DS, but they are not very much comfortable with the practical part of DS. Okay, but you have to handle both. So if you don't ask for help, you won't get help. Okay, so do not hesitate, do not think ki what others will think of me. All right, what others are going to think of me if I'm going to ask. Please do not think like that, just ask. Okay, fine. See, now we are going for the next operation, that is delete operation. I'll just present my screen so that we can discuss the flow. I can show you the coding and then you can code for yourself. Okay, I suppose my screen is visible to all. All right. See, we are done with 3 programs. Okay, so half of this practical is over. Fine. Now we are going for delete the first node of your linked list. So far, we have inserted the node. Fine. Now we are going to delete the node. All right. So let's see the algorithm first. We have seen delete the node from the beginning of the list. Fine. So what does your step say? First of all, you have to check if start is equals to null. Okay. So that means your singly linked list head pointer is pointing at null. If it is pointing at null, then there is no singly linked list existing. Okay. So you can execute this step number 1. I'm going to keep it side by side so that you can see the Okay. I joined again. Okay. So see, first of all, you need to add that to your menu. Okay. So this 4, we are going to keep it as now delete from beginning. Wait. Okay, that is what you are going to write. So delete from the beginning, here /n/t and number 5. Okay, because it is display is now going to be my number 5. Okay, so case number display will be your case 5. Before that, case number 4. Okay, and here you are going to write a meaningful user defined function name, delete from begin. Okay. And your break statement. Fine. Now this you can copy to avoid any spelling mistakes or mismatch, name mismatch. Okay. And wherever you have written your insert in ascending order, after that you can write one more user defined function, void delete from the beginning. Okay. Now what is our step 1 here? This side on your right side. What is your step 1? If head is equals to null, so you have to write here. If your head is equal 0, then a simple printf statement, SLL does not exists. Okay. All right. If it is existing, all right. If it is existing, then in the else part, what you are going to do? Take your temporary pointer to start. Okay. So temp is equals to head. Now we want to free up this temp because we are going for delete function, right? And what we want to delete, the very first node. Okay, the first node right now is pointed by this head, right? So we need to move your head to the currently second node. Why? Because when we delete that first node, that second node will be your new first node, right? So we are going to move this head value. Head is equals to head of next. Okay, and then you're calling your free function, and inside that free function, you see here, this is free function void pointer memory. That means a pointer which is pointing to your memory. Okay, so temp is the pointer of our targeted node to be deleted, so free temp. You can also write one printf statement for the user. Okay, %d is the value getting deleted. It is not yet deleted, so that's why getting deleted. Okay, and there what you can print, wherever your temp is, obviously your first node. Okay, so that data you are going to print for user to know that printf this data is getting deleted. Okay, then you are calling your free function here. Okay, this is what call for DMA free function, dynamic memory allocations free function. Okay, for what purpose? To free up your memory. Fine. So we are calling that free function, and then we have to exit. Okay, fine. This is how we are going to write a code. Let's see if it is working. Entering the node 50, 65, 75, 0. So 50, 60, 75 is there. Okay, now I want to delete from the beginning. So 50 should get deleted. Correct? So number 4. 50 is the value getting deleted. So I suppose it is right. Let's see, let's verify it. I want to continue. Yes. Display, I'll go for number 5. See, I have just two values, 65 and 75. Okay, so 50 is deleted. Still my 0 is not working. I need to work on that. Okay. Got it? How you are going to write your delete from the beginning? Okay. Anybody else done apart from Vijay? See, this is the algorithm you can refer. Okay. Anybody anybody having any doubt? You want to repeat after step 3? Okay. See, this free PTR is what? Your free PTR is, it is a free function. Okay. What is this free function? This free function is the part of your dynamic memory allocation. Okay. If you can remember our practical number 2, where we have implemented calloc, malloc and free function. Okay, so this free function is the function of your dynamic memory allocation which frees up the memory of the pointer which is passed. Okay, so temp is the pointer which we passed, right? So wherever this temp is pointing at, that particular memory will get freed up. Okay, so we are calling that free function, and that is what your step number 3 is, free PTR. But before freeing that PTR, we are moving our head, okay, to head of next, so that once we are freeing up this temp, the new first node. Okay, it is pointed by your head. What we are doing here is, I can show you. I cannot go back to that Excel because that Excel is now messed up. So I can just show you it like this. Okay, try to visualize. See, when we are talking about this else part, okay, here this is my single linked list which is existing. Okay, these are the memory addresses. Okay, now see, my temp, I am getting it pointed to my head value. That means temp, I am pointing it towards my first part. Okay, so temp and head, they both are pointing here at data 26. Now this is what delete from the beginning. So I know that this particular node is to be deleted. Now my head cannot point towards a null value. Okay, I need to make this head point to this node which is 45. Why? Because after deleting this particular node, this 45 is going to be my first node. Okay, so in the next line, head is equal to head of next. So I'm pointing this head to this particular node. My temp is still here. Okay, I'm telling my user that which data is getting deleted. So 26 is the data which is getting deleted, and then I'm calling my free function by passing the temporary pointer. So what we are doing, we are basically removing this particular node. Okay, so see, now also your single linked list property satisfies. Head is pointing to the first node, last node is having null value. Okay, so this is your delete from the beginning. We can see one more function. Okay, next is delete the node before the specified position. Okay, next your operation is what? Delete a node before the specified position. Okay, so what are prerequisites here? Okay, we are going for delete before the specified position, or you can take data also. Okay, now see, what are your prerequisites? First of all, you have to take value, okay, before which you want delete operation. Okay, so you need to take a value from the value. This value is what? The value which is there in your existing single linked list. Okay, so you are going to take that value. Then second, you are going to traverse. Okay, you need to traverse in your SLL to reach that particular value. Okay, that value which is specified. Once you reach that value, then you operate, or say write the code for free function. Okay, this is how the flow is. All right, now see, in our program, first of all, what we are going to do, we are going to add the menu here. Okay, so if you don't want to write this long now, what you can do is you can just copy this printf line, okay, and paste it here. Fine. Now this is what you can do this editing part, okay, on your end. Now see, this we had till number 5, I suppose. Yes. Now number 6. delete at beginning. Okay, that is number 6. Fine. So case number 6 here. Let your case file be display only. Case number 6. Okay. Write a meaningful name. Delete before. And your weak statement. Alright. You can arrange this menu once we are done with the full program. At that time you can keep this display at the end. Okay. Right now you can avoid wasting that time. Again, write your delete before. Fine. Again the same condition. If head equal 0, printf SLL does not exist, else printf enter the value before which you want delete operation. Okay, so some value will be inserted by the user. This value is from the existing singly linked list. Scanf and store it somewhere. So percentage D. Let's say we are taking it in value called val. Okay, so declare that val. Fine. Now what you are going to do? You need to traverse. Okay. So traverse till the required node. You see what will be your traversal part. Now you see these steps are the common ones. Okay, so you don't need an algorithm to look at. Now see, we are going to compare with the algorithm. This was for the beginning of the list. You have to see for before. Okay, before is, I have not written here before. Just wait. Okay, it is not there. Fine, no problem. Focus here. While temp of data, okay, is not equal to val. All right. So you are going to take your temp equal to head. All right. Now see, temp of data not equal to val. What you need to do is, this can be done with the help of one pointer also. This can be done with the help of 2 pointers also. Okay. This particular UDF function, you can do it with the help of one pointer also. You can do it with the help of 2 pointers also. We are going to go with 2 pointers right now. Okay, because you are familiar with pre-temp and temp. So temp of data is not equal to val. What I need to do? My pre-temp equal to temp. Okay. Temp equal to temp of next. Fine. So I just delete before. Let's solve it with the example parallelly. Okay, this is my example. Okay, what I did, my head is equal to temp. Okay, the value which is inserted before which I want the delete operation, let's say it is 66. Okay, so which is the target node to be deleted? This one. This is the node which is to be deleted. Okay, this 58. Okay, because value I gave 66 and this function is for delete before the specified data. Okay, so what I'm going to do, temp data is what? 55. 55 equal to 66? No. So what I need to do, I need to give pre-temp wherever the temp value is stored. So pre-temp is here, temp mode forward. Now again, temp data 58. 58 is equal to 66? No. So what I need to do, move my pre-temp. Pre-temp to where? Wherever temp is pointing at. Okay. So pre-temp is now at 58. Temp is moved next. So temp is at 66. Now see, 66 not equal to 66. So that is false. So now we are going to stop our while loop. Now what we have to do is, see, this node value, we know that this is going to get deleted from between. Okay, but right now this first node is pointing to this node, right? So we need to update this one, okay, with the value 2. Why 2? Because it is the memory address of this node, right? We need to update that, and along with it we need to afterwards free up this memory also. Okay, so what we are going to do, first of all, here head of next, okay, equal to which value? Pre-temp of next. Why pre-temp of next? Because 2 is the value which we want to store, so that after we delete this node, okay, after we delete this particular node, we can create the linkage between this 45 and 66. Okay, so head of next is equal to pre-temp of next. Okay, afterwards what we are going to do, write one printf statement, printf %d is the value getting deleted. Okay, now what is the value that is getting deleted? Wherever my pre-temp is pointing at. So I'm going to print pre-temp of data part, correct? And then I'm calling my free function and freeing up my pre-temp value. Okay, understood this much? Any doubt till here, anybody? Okay, I have one answer. What about rest? Okay. All right. But don't you think there is one problem here? Can you analyze what is the problem here? Look at the program which I have written. Okay, it is correct with what case I have taken. With that, it is correct. Absolutely right. I am going to, free up the targeted node. But there is a problem. Can you identify that problem? Yes, you are nearby. Okay, let's make a deal. I'll tell you what the problem is. You have to think for a generalized solution. Okay? I'll tell you what the problem is. This code is going to run perfectly. Okay, with the example and the case which I have taken here. Okay, it is not going to give any wrong answer. It is going to run very perfectly. I am going to get the desired output also. But the problem is when I select, right now I selected 66, okay, which is the third node here. But what if I select 75? Okay, so at that time, what will be the position of my pre-temp and temp? It will be like this, right? Now what I am writing here, head of next equal to pre-temp of next. So this head of next, this part I am writing as this pre-temp of next. So where my head is going to point at, it is not going to point at to this second node, it is going to point to this last node then. Though this second node is still existing. Can you see the problem? My head, if I keep this particular program, then in the second case, my head is, going to point not to the second node, but here to the last node. So basically this link will get delinked. Okay, of course this one is getting deleted. So can you see the mess? The node is already existing, the second node is already existing, but there is no chaining, the actual chaining. What should be the actual thing? Head node should be pointing to this second node and this second node should be pointing to this last node. But that is not the case. So how can I generalize? You have to give me the solution now. How can I generalize? That it works for every case. Can you think of any solution? See, this code is also going to run. Okay, I'm not saying this code is wrong. It is going to run for this particular case. When the required node is 66 is the value, okay, and 58 is the value which is to be deleted. Okay, so third node is the specified value and second node is to be deleted. At that time, these 3 lines of code will give you the correct output. Okay, but it won't be the correct answer or say correct single linked list chaining when we are going for more than 3 nodes. In that case, what you can make changes in this particular line of code. See, I gave you the hint also. Now you should be able to answer, at least few of you. Okay, do one thing. Take a screenshot of the screen. Everybody, take the screenshot. You have this example in front of you, okay? Keep this example in front of you. Value to be deleted is no more 66, okay? Value before which I want to delete is 75. Okay, now you take the screenshot so that you can identify what you need to do. The specified value is 75. Okay, and you have to modify this line of code so that this particular function is running for each and every case, not just one case or case where you have only 3 nodes, but it is working for more than 3 nodes also. And this is the line. Okay, I already told you this is the line where you need to make some modification. You have to think of some solution here. Got it, everyone? You have got 1 week to think of for the solution, and it is very easy solution. Okay, second hint. First hint I already gave you that you need to do some modifications here. Second hint, there is one more third pointer. With that help you can modify here. Okay, I gave you 2 hints. I gave you the issue. Come up with some solution by the next lab. Okay, we are going to continue from here. And everyone, again, do not forget to safe keep your program. This program should be saved somewhere, kept safely. If you are not able to, keep it save it due to some compiler issues, then copy paste your program into a notepad file and save that notepad file, because you are going to need this program. This is almost now 215 line of code. So you cannot go and write down that code again. Fine? We are going to keep our session till here. Do not forget to solve this issue. I already told you hints. Also, I gave you 2 hints I've given. You can keep this commented example for your reference to think for the generalized solution.
मैम एक बार रन करके दिखाओ ना प्लीज।
वापस वापस क्या?
रन करो, रन एग्जीक्यूट।
अच्छा, कौन सा फंक्शन, ये वाला?
हाँ मैम।
ओके, एंटर द नोड डेटा, यही वाले डालती हूँ। ठीक है, तो सामने है तो सही रहेगा। 45, 58, 66, 75, 2 और डाल देती हूँ, 85 एंड 100। ठीक है, अभी डिलीट, ओके मैंने सेम ही रखा है। डिलीट एट द बिगिनिंग मैंने चेंज करना मैं भूल गई। ठीक है, नंबर 6 वही है ना, देखने दो। 6th case delete before. Okay, number 6, enter the value before which you want to delete the operation.
तो विजय
हाँ
इंसर्ट एट एंड वाला बाकी है ना अपनी लैब में, या फिर मैंने नहीं लिखा है?
एक मिनट, मैं डिस्कनेक्ट हो गई।
मैंने तो कर दिया इंसर्ट एट एंड।
Able to see my screen?
Yes, ma'am.
ठीक है। ओके, सही तो चला है, मुझे डीबग करना पड़ेगा क्या इसको? नो एरर मैसेज। देखते हैं कहाँ पे इश्यू है। नॉट अरे यार, सिक्स 66 वाइल में प्रॉब्लम है, वाइल के अंदर ही नहीं जा रहा हूँ। temp is equal to head। oh god, ऐसी सिली मिस्टेक्स होती रहती है। देखो 45 अब चलना चाहिए, 58 66 75 85 delete before 66 want inside while okay, while outside 58 is the value। ठीक है, while loop चल रही। want to continue yes, देखते हैं डिस्प्ले में आ रहा है। नंबर 5 हो गया 58, आगे से डिलीट। लेकिन ये चीज नहीं होगी जब मैं 85 डालूंगी तो गड़बड़ करेगा वो।
तो 70 आ जाएगा।
हाँ, तो इसीलिए तो बोला कि ये जो केस अभी लिखा है यहाँ पे, ये वाला जो केस हमने लिखा है डिलीट बिफोर में, ये वो चलेगी सही में, लेकिन कब? जब आपको सेकंड नोड डिलीट करना है। लेकिन ये चीज सही तो नहीं है ना, डिलीट ऑपरेशन तो मतलब कहीं से भी मैं दे दूं, तो वो तो कहीं से भी चलना चाहिए। आप लोगों को एक जनरलाइज्ड सॉल्यूशन लेके आना है। उसकी 2 हिंट भी दे दी मैंने। हिंट नंबर 1, मॉडिफिकेशन ये लाइन पे 137 पे, ओके। एंड हिंट नंबर 2, एक थर्ड पॉइंटर की हेल्प लेनी है। ठीक है, 2 हिंट दे दी, मॉडिफिकेशन भी कहां होगा वो भी बता दिया, इस लाइन में। ठीक है, इसका जनरलाइज्ड सॉल्यूशन नेक्स्ट लैब की सेशन में।
मैम
ओके,
और इंसर्ट एट एंड बाकी है अपनी लैब में।
बाकी मेरे को तो बोले 2 हो गए, दर्शन ने भी मुझे बोला कि 2 हो गए हैं, इंसर्ट एट द एंड और बिगिनिंग। पहले ही पूछा मैंने।
मैम वो आपने कुछ करने को दिए थे ट्राई करने को।
ठीक है, कोई बात नहीं, नेक्स्ट सेशन में वो भी करवा दूंगी। ओके
यस मैम।
फाइन। Chalo. We are going to keep our session here. Thank you all for attending the session. Yasin, write your numbers and you can leave the session first. Raj, ruk jao. Okay. All the AI students in serial order. Write your numbers in the chat and you are free to leave the session. Thank you all. हर्षवर्धन पिक्चर मिल गया हाँ सॉरी मैं तुम्हें कहना भूल गई थी सही किया है